Hey kids, it's Miss Floyd here bringing you chapter 13.6, the Fundamental Identities. So this is a trigonometry. Basically what we're doing in this section is we're going to be spies and we're going to be decoding a bunch of different trig functions. So this is basically a way you can write the trig function one way or some other way in order to simplify it down to one or in order to expand it into something larger. So here are the reciprocal identities, so things that we've kind of gone over before already and things that are in the formula sheet for my kids. And so sine and cosecant are reciprocals, so all of these are just different ways of writing that relationship between sine and cosecant. And then cosine and secant are reciprocals of each other, so this is just different ways of writing down that relationship of the reciprocals. Same with tangent and cotangent. And then the last one down here is looking at tangent as a way of writing sine and cosine. So we know tangent is the y over the x, sine is y, cosine is x. So sine over cosine, and then cotangent is a reciprocal of that, so it'd be cosine over sine. So these you would want to have handy whenever we're doing these proving or simplifying of the trigonometric expressions. So then here are cofunction identities, so different ways to write sine and cosine when it comes to each other. So using that 90 degrees. Same with tangent, cotangent, and secant and cosecant. Again, these are things that are given, and as we get to each of the problems, it'll be a little bit more obvious on which ones you would want to use. And then my Pythagorean identities. So this first one should be very recognizable because this is my very embarrassing pickup line that apparently never works. So if you were sine squared and I were cosine squared, together we could be one. So there's that. And then there's a similar version for tangent squared, secant squared, and cotangent squared, and cosecant squared. So these are things that we're going to look into when it comes to simplifying or proving any of these trigonometric functions or expressions. So here for the first one, when it talks about simplifying, what it wants you to do is simplify down to one trig function if you can. So you just shrink it down. You should be able to shrink it down to a trig function or a trig function and a number. And my first step when it comes to that, or the first thing that you should try, is to change everything into sine or cosine. So looking at this first one, I have cosecant of theta minus cosine of theta times cotangent of theta. There's a lot of cos in there. So cosecant I know is a reciprocal of sine, so I'm going to replace that with sine over theta because, or 1 over sine of theta, because I know that that is the same exact thing. I'm going to keep my cosine theta how it is because it is the cosine. And then my cotangent, I know tangent is sine over cosine, so cotangent is cosine over sine. So I'm just replacing anything that's not cosine or sine with cosine or sine, some version of it, whatever that is equal to. So now I can say, all right, this cosine is multiplying with the cosine over sine, so I'm going to multiply that in. I know this is over 1, so this would turn into multiplying across the top, cosine squared of theta. Whenever we multiply cosine times cosine, we end up with cosine squared. And this will be over my sine theta. Whenever I multiply 1 and the sine, it just ends up with sine. And this is still 1 over sine theta in front. I haven't done anything with that. Now looking at this, I can see that I have sine of theta as the denominator for both. Because they have the same denominator, I can squish them into one fraction. So 1 minus cosine squared theta all over sine theta. And so now I have a cosine squared theta. And I have two trig functions, so I know I shouldn't be done. I have a cosine squared theta. The only time we're working with squares of these trig functions is when we're looking at the Pythagorean identities. So I'm going to go to the Pythagorean identity. And the only time we have a cosine squared theta is with the first one. If I were to subtract my cosine squared theta over to the other side, it would end up being sine squared theta equals 1 minus cosine squared theta. So every time I see a 1 minus cosine squared theta, I can replace that with sine squared theta. So then here, that I'm going to replace with sine squared theta. It's going to be over sine theta. And this works very much the same as if I were to have an x squared over an x. We said before, in order to get the cosine squared, it would have been a cosine times a cosine. So this is basically sine theta times sine theta over my sine theta, meaning that one of those is going to be canceled out, and the only thing I'm left with is a sine theta on top. And we're done. I've gotten it down to just one function, so that's as far as we need to go. It's as far as you can go. You could like actually keep manipulating this until we're all dead, but it's down to one function, so that's where I'm going to draw the line. So when it comes to proving identities, so before we were simplifying down into one function, when it comes to proving, this is when we have some trig stuff equal to some trig stuff. So when we do that, there's two strategies that I use. One is to simplify the more complicated side until it's identical to the less complicated side. So you just work with the one side, try to change it just like the way we simplified until you get the two sides the equal sign to match. The other one, if they're both super complicated or annoying, just start working with the left side, simplify it as far as you can. If you get stuck, then you start working on the right side, and then you simplify that until you get stuck. The goal for all this, though, is for both sides to be identical or the same. So you want it to be equal. And one very important thing when it comes to this, especially for my students, especially for my advanced kids, because they don't always show their work, you need to show every single step whenever it comes to this. Like all of your work, every single thing that you're replacing one thing with another with, you need to show what you're replacing every single time, just like I did in the previous example. You don't have to necessarily say reciprocal identity or Pythagorean identity or anything like that next to it, but you do need to show some sort of work. You can't just say like, oh, sine is equal to sine, okay, done. Like this, that's not how that works. It's not how life works. So here we have an example. So obviously, just looking at it, the left side is a heck of a lot more complicated than the right side. So I'm going to go with my first strategy and just work on the left side and try to get all of this mess to equal secant squared theta. So again, whenever I'm doing this, one thing that I like to start out with is just the same way that I simplified before. So I'm going to try to turn things into sine or cosine. Because this is secant squared theta though, I want to keep that Pythagorean identity in mind. So that was the 1 plus tangent squared theta is equal to secant squared theta. Because I already have a tangent squared theta, that means this stuff is going to have to somehow squish down into equal to 1. So I'm going to figure out how to do that. Again, first off, so I may want to keep this just tangent squared theta since I have that secant squared theta and I know that those are together in the Pythagorean identity. So I'm going to work on this thing here, the 1 over cosecant squared theta. So I know that cosecant is the reciprocal of sine. So this is going to be the same as sine squared of theta. Whether they're squared or singular, their reciprocals work the same way. And then I'm going to leave everything else the same so far. So again, a lot of times it seems like where is she seeing this? It's because I've been doing this for years. I know kind of what to look for. For you guys, it's going to take a little bit longer to get the hang of it, but the more that you practice, the easier it's going to get, I promise. It's the same as a language. People compare mathematics to languages all the time, every single day. So this is one of those cases where the more you do it, the more you use it, the more it starts to make sense. So now looking at what I have left on the left side, I see my pickup line. Cosine squared theta plus sine squared theta together, they make 1. So then now I have tangent squared theta plus my 1 is equal to secant squared theta. And because of the Pythagorean identity that I showed up above, I know that tangent squared theta plus 1 is equal to secant squared theta. And now my two sides of the equal sign are identical, so I'm finished. Ta-da! I've proved it because I'm smart. And I know my identities because I practice with them a lot in order to get to this stage in my life. So now there are some special strategies, some additional strategies for proving some more difficult identities. So you can go ahead, I'm going to speed through these and then, actually no, I'm going to pause myself, write it all down, and then I'll talk through them once I've gotten them all written. Okay, so these are all different strategies. You can try one, and if that doesn't work, try something else, kind of keep going back. A lot of times, just 5 problems will take you half an hour or longer whenever it comes to these identities, just because you don't necessarily know which strategy is going to pan out. So the first one we've already talked about, changing things into sine and cosine. Second, looking for expressions to which you can put in or use the Pythagorean identity. So if you see those squares coming in, you can use factoring. And I put in an example with sine squared. You can change that to 1 minus cosine squared theta, and then that's a difference of squares. So 1 minus cosine theta and 1 plus cosine theta. You can combine the terms on each side of the identity into a single function, so try to get everything down to 1. So it's kind of like before, whenever you're looking at one side at a time, you can try to just simplify everything down into one function and get each function to be the same on each side. And then one of the last case scenarios is to multiply one side of the equation by an expression that's equal to 1. An example being sine theta over sine theta. So maybe you think, oh, if I had a cosine or a sine squared theta in here somewhere, then that would help me out. So it depends on what you see. I can't really give you a great example just by talking it. It's just what comes up. And you have to be able to tell what will work for each one. So sometimes that means that you're trying out every single one until one works. And that's totally fine as you're starting out with this. So one of the first examples for these. So for this one, we have 1 plus cotangent squared theta over secant squared theta, and that is all equal to cotangent squared theta. So looking at this, I have something simple on the right side, something more complicated on the left, so I want to worry about the left side first. I notice that I'm probably going to have something that's Pythagorean-esque with that 1 plus cotangent squared theta. So looking at my Pythagorean identities, I know that 1 plus cotangent squared theta is equal to cosecant squared theta over secant squared theta equal to cotangent squared theta. And I'm going to leave the right side by itself. It's just going to stay what it is. Since it's already down to 1, I'm just going to be fine with it. So from here, I can't really do any Pythagorean identities because there's no 1 involved anymore. So I'm going to try to change things to sine and cosine. So I know my cosecant is 1 over sine squared theta, and that my secant is 1 over cosine. And this is still equal to cotangent squared theta. And from here, I have a fraction over a fraction, so I'm going to do the same change flip. So I'll have 1 over sine squared theta multiplied by the reciprocal of this, so cosine squared theta over 1 equals cotangent squared theta. And then multiplying this through, I have cosine squared theta over sine squared theta. And I know that cosine squared theta, or cosine over sine, just cosine over sine is equal to cotangent. So then the cosine squared over the sine squared is going to be equal to cotangent squared theta. And we're done. We've got the one side equal to the other. And there are always a few different ways to approach some of these. Maybe instead of leaving it as cotangent squared theta, you changed it to sine and cosine to begin with, that's totally fine. You would have been stopping at that area because you would have had cosine squared over sine squared equal to cosine squared over sine squared if you wanted to do it that way. Again, there are a few different ways to do this, so maybe my way isn't necessarily the way to do it, but it's one of the ways. All of our minds are different. We like to celebrate that in my class. So it's totally fine if you see another way of approaching this that I didn't. All right, so next they want to simplify. So again, we're trying to break this down into just one trig function. Again, I see the 1 minus cosine squared, and I know that that's a Pythagorean identity, so I'm going to change that to my sine squared. This is going to be over sine times my cosine. And because I have that sine squared, I know that's the same as just sine times sine, which means that I can cancel it out with the sign that's on the bottom. So that'll go away. Bye, Felicia. Sorry if there's a Felicia, please don't go away. And then I have sine over my cosine. And I know sine over cosine is one of my reciprocal identities that is equal to tangent. And I've gotten it down to just one trig function, and we're done. So if you're one of my students, you can find the homework on LMS. Don't worry, it's not every single one of those. I have my students pick however many from each of those sections. So there'll be a few sections for them to pick from, but for this, there shouldn't be more than 6 questions you have to do because this is a bit of a doozy. It does take a lot of practice, which is why we're dedicating an entire day of this tomorrow so that you have some time to really look through some of these. So those of you who are not my students, I hope you have a wonderful day. Please like and subscribe. Share this with someone who you think might need it. Even if you are one of my students, like and subscribe and share this with someone who you think might need it. And I will catch you guys next time. Spread the love.